One of the questions in the homework quiz gives you a polynomial. They give you a complex zero. They ask you to find another zero. So the easy way to do that is to understand that, so this came from the textbook, and I'm going to come back and do this question all out for the way the textbook has asking, but I'm going to just directly answer the question from the homework quiz. If 1 plus 3i is a zero, and we know these complex zeros come in conjugate pairs, that just means 1 minus 3i is going to be a zero. So it doesn't require any more work than that. There's a lot of background here that we got to understand. So what I'm going to do in the next few minutes here is give you some of that background in case the lesson didn't work for you to understand that. Okay, but this is how you answer that question in the homework quiz. So here's a question I made up. It's a nice, easy question, so that's why I thought I'd do it for you. They gave me this polynomial. They just want me to find all the zeros. Well, I know from the fundamental theorem of algebra that there's supposed to be 4 zeros, right? And when I graph it, I see these 2. And sure, you could do that rational root theorem. You could do Descartes' rule of signs. That all works. It's all good stuff. In 2021, when I'm recording this, why? I graphed it. I see these 2 zeros. I know they're supposed to be 4, so that means there must be 2 of them that are complex because I'm not seeing it. So I see x equals -7 is a 0 because y equals 0 there, and I see 2 is also a 0. So what I want to do is I want to remove those from this polynomial so I can get down in the nitty-gritty and find the other 2. So I know these 2 x values are zeros for this polynomial. If I substitute in -7 in for x, I'm going to get 0. If I substitute in 2 in for x, I'm going to get 0. So let's remove those zeros to see what's left, because I know what I'm trying to do is factor this polynomial, right? So the easy way to do that, and this is why they talk to you about synthetic division, is we'll just do some synthetic division with these 2 zeros. Remember, you put the -7 outside, and then you pull the coefficients off the terms, and I'm not missing any powers of x, so I don't need to put any zeros in. Remember, if I had a missing, like if I didn't have this, where's a pointer? If I didn't have this x cubed term, I'd have to put a 0 in for that 3, but I do, so I don't have to worry about that. So then synthetic division, bring down the 1, and now we multiply, and we add, we multiply, and we add, we multiply, oh my, what is that? That's 70 plus 70 plus 28, is that 98? Oh man, let me get a calculator here. I've got till the end of the day. I know what I'm doing here. Where is it? I better not trust my arithmetic skills right now. 7 times 14 is 98. I should have trusted myself. So -98. And then that's going to give me -20, and -20 times -7 is 140. We get 0. We knew it was going to be 0. So now let's go ahead and just remove the x equals 2. And we'll just do the same process all over again. That gives me 2, gives me -2, gives me 4, which is 18. No, Dan, what did I do? -4, which gives me 10. You probably saw that. 10. And 10 times 2 is 20, and there you get 0. Okay, so what's left? What we've just done is, here, let me move this up. Let's move this up. So I just factored that polynomial into x plus 7, because it's my x equals -7. I bring it over. And then x minus 2, and then I've got x squared minus 2x plus 10 left. Okay, now I could try to factor this, but I'll tell you right up front, I deliberately made it so it doesn't factor. So what I'm going to do is pull this all up out of the way. I want to find out where does x squared minus 2x plus 10 equal 0. Well, it doesn't factor, so that requires me to use a quadratic formula. Or I could use completing the square, but I don't know if anybody ever does that. So remember, the quadratic formula is -b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. For this problem, a is 1, b is negative 2, and c is 10. So negative 2 is 2, plus or minus the square root of 2 squared, negative 2 squared, which is 4, minus the 4 from the formula times the 1 from the a times the 10 from the c all over 2 times 1. So that's going to give me what? That's going to give me 2 plus or minus the square root of, isn't it negative 36? Because it's 4 times, let's see. Order of operations says to multiply before we add or subtract. So negative 4 times 1 times 10 is negative 40. 4 minus negative 40 is negative 36 all over 2. So then I'm going to get 2 plus or minus 6i, right? All over 2. Then I can factor out of 2 and cancel, so I'm going to get 1 plus or minus 3i. So my two other zeros are 1. So I've got a 0 at x equals negative 7. I get a 0 at x equals 2. I also have x equals 1 minus 3i. I also have x equals 1 plus 3i. So do you see how the complex numbers, or the complex solution, I mean, gives me two answers, and they're just conjugate pairs, and they're conjugate pairs because of the plus or minus. I mean, one's a plus, one's a minus. So if we go back and think about that very first question there, let's see, let me add a page. It said, I don't even remember what it said, just a minute. So that original question that I had out of the textbook, it said, hey, 3 plus I is a 0. 3 minus I is also a 0, and that comes from that quadratic formula. Okay, so that's that. And I don't know, I guess that's what I wanted to do with this video. Maybe what I'll do in the next part is actually answer the question here that said, find all zeros of that x to the 4th problem, number 36, okay? All right, so what I see, I'm tackling this the same way as I did the other one, is I tried graphing it to see if I could find any real zeros. And I see there's 2 real zeros, but those aren't integers. Those aren't very nice numbers. So I really need to come up with another way of doing it. So here's the other way to tackle this. Okay. So I know that these complex zeros come in conjugate pairs. So that tells me that is 1 0. And here is the other 0, negative 3i. Let's see if we can't get rid of, remember how I factored out those real number ones? We can do a similar thing with these complex ones, but we just got to do a little algebra before we get there. So I'm gonna isolate those 3 i's for a minute. And now I know the I is coming from taking the square root of negative 1. So if I square both sides of these equations, that gives me, let's see, what does it give me? So that gives me x squared minus 2x plus 1. Remember, we're going to FOIL that. And I get 9i squared, and of course we know that I squared, and actually let's go to the other one. Don't we get the exact same thing over here? Plus 1 equals 9i squared. So I don't have to do both of these because they're both the same. The two answers are coming from the plus or minus in the quadratic formula. So I know that x squared minus 2x plus 1 is going to be equal to negative 9 because I squared is negative 1 times 9 is negative 1. So I'm going to get the x squared minus 2x plus 10. So that's where those two complex zeros came from. Now I want to be able to remove that. So that's a factor times something else, which I don't know what it is, will give me that polynomial. So what I want to do is remove those so that I can do whatever I need to do to find those, that negative 2.73 and positive 0.73 or whatever it was. So x squared, I'm going to write this right here so I don't lose that, so then I can erase some stuff. Okay, so unfortunately, because these are not real real numbers and they aren't linear factors. I mean, I could do synthetic division with a complex number, but really, who wants to do that? So what I've decided to do is I'm going to take that polynomial that I got from the complex zeros and do some long division with this. And if it's been a while, I mean, you probably looked at it in the lesson. I asked myself, what times x squared is x to the fourth? Well, that's, of course, going to be x squared. And so x squared times x squared is x to the fourth. X squared times negative 2x is negative 2x to the third. X squared times 10 is 10x squared. And then just like we do with regular division, I need to change the signs. I need to subtract. So the x to the fourth's gone. Even with this one, the x cubes are gone. So that leaves me negative 5x squared plus 10x minus 50. Then I say, what times x squared, right? What times x squared will give me negative 5x squared? Well, that just so happens that it's negative 5. So I'm going to get negative 5x squared plus 10x minus 50. And then, like I said, I got to change the signs. And then I get 50. I'm sorry, I didn't write 50 here. 5 times 10 is 50. So that's gone, that's 0, that's 0, that's 0. So I'm done. Now that factored. And I knew it was going to factor because I knew those were zeros, but I didn't know what it was going to factor to. So now I've got to ask myself to find those other two zeros. Where does x squared minus 5 equal 0? Well, isn't that equal to the plus or minus the square root of 5? And sure enough, that's what the calculator, what Desmos was showing me, was what is the square root of 5? 2.24 I'm getting on my calculator. So that checks in that. So that's how you can find all zeros. And then they want us to write this as a linear factorization. So I guess to do that last little piece, here, can I erase that division without losing everything? I think so. Yes. Okay. So what's my linear factorization? Well, I've got to deal with the complex numbers here. Plus 3i. So that's that factor. Then I'm going to do x minus, right, because I know I'm making a jump here that I don't want to lose you. If I have x equals 1 plus 3i, don't I want to subtract that whole thing and bring it over the minus? And same thing if x equals 1 minus 3i, I'm going to bring that whole thing over, put it in a minus. And then I'm going to get x, the other factors, I'm going to do x minus the square root of 5, and then x plus the square root of 5. That's just coming from here, bringing them both over. So those are the linear factors that they're asking for. What good are those? I don't know. I mean, with the complex numbers, it's kind of weird. And you could certainly also multiply the negative through here. So minus 1 minus 3i. So I write 2. Okay, what am I doing here? Minus 3i. And then I can do x minus 1 plus 3i. And then I can do that too. All right, so that's what they're asking you to do in income and all here. And there's a question that you have to do in this unit about that. So hopefully this helps.